Okay, by and large, the class did very well when we were talking about beating and resonance in section 4.3. There were just a couple of issues that I wanted to address. So people had no problem finding the general solution. So I'm just giving you a general solution to something where there's going to be beating, okay? And I'm saying the coefficient here in front of the cosine 4.1t is negative 100 over 81. I'm just telling you that came from negative over 1 over negative 0.81. Never a good idea to mix fractions and decimals like that. And a lot of people either left things like this or rounded. And the directions always say don't round. I want exact answers. So the simplest way to convert that to a nice fraction is just multiply by 1 in the form of 100 over 100. That's going to give me, I'm going to just bump the negative up to the top, 100 over 81, because that just moves the decimal. Okay. All right, now, if I were going to graph this, what I would care about was the amplitude of the beats, the period of the beats, and the number of rapid oscillations per beat. Okay. Now, the amplitude of the beats is going to be the amplitude of the natural response, which is just the square root of k1 squared plus k2 squared. That, of course, is because I could rewrite this as c copies of cosine of 4t minus phi for certain values of c and phi. The way we figure that out is by drawing this lovely triangle. I'm going to draw this as if k1 and k2 are positive. Obviously, they could be negative, in which case I would draw things in a different quadrant. But I would put a side of k1 here, k2 here. The one associated with cosine is what's going to go on the x-axis. The one associated with sine is what goes on the vertical axis. And then I draw in my phi, and this is c. So c is always just the square root of k1 squared plus k2 squared. You don't even need to draw the picture in order to get to that amplitude. The picture is helpful in figuring out phi because tangent to phi will be k2 over k1. Now, of course, if one of these is negative or if they're both negative, I'm going to be drawing my picture in a different quadrant, so I'm not necessarily going to get arctan of that angle depending on what quadrant I'm in. Okay. But the amplitude of the natural response is always just this. The amplitude of this is 100 over 81. So if I look just at this, the amplitude is the absolute value of negative 100 over 81. Amplitude cannot be negative. Okay. So the amplitude is the absolute value of the coefficient in front of your trig function. Now here, this is not negative, so I don't need to worry about an absolute value sign. Got a 50-50 chance that this is going to be positive or negative. If it's positive, I can just take that number and that's the amplitude, but if it's negative, I have to take the absolute value, which involves changing the sign. The basic idea is that when there's beating, there's a point at which this is at its high point at the same time this is at its high point. And the high point here isn't negative 100 over 81, it's positive 100 over 81. Okay. So don't forget that absolute value. That was the big thing that people struggled with on the quiz that related to this. For the most part, people were pretty good about finding the rest of the information. So I'm just going to list the number, the associated period, and the associated frequency. Okay. So alpha would be 4 plus 4.1 over 2. 4.1 is the angular frequency of the forced response. 4 is the angular frequency of the natural response. We're just averaging them. Notice that gives me 8.1 over 2, which would be the same as 81/20. Again, just using that technique of to avoid having a decimal, multiply by 1 in the form of the appropriate power of 10 over itself. Now that means that the period is 2 pi divided by that number. So that would be 2 pi times the reciprocal times 20 over 81. So that would be 40 pi over 81. Beta is, oh gee, which one is it? I can never remember the order in which we subtract things. So I'm just going to say the absolute value of beta is the difference between these divided by 2, which would be 0.1 divided by 2. That would be 10, sorry, that would be 1 over 20. Okay, so the associated period is 2 pi times 20 over 1. Sorry, that was a 2 pi, which would be 40 pi. Okay. The associated frequency is just the reciprocal of the beat. So this is 81 over 40 pi, and this is 1 over 40 pi. So the bigger period is the period of the beats. That would be 40 pi. And this frequency is 81 times as big as this frequency. So there would be 81 rapid oscillations per beat. Okay. Again, for the most part, people did pretty well with this. The thing to look out for is remembering that amplitude can't be negative. Okay, just one quick note on resonance. Again, people did very well with solving the differential equations that had resonance. So I'm just going to give you a solution, and we'll talk about graphing it. Let's suppose I had y is k1 cosine 2t plus k2 sine 2t plus t over 5 cosine 2t. Okay. So this would tell me that the slopes of the lines between which my oscillations occurred would be plus and minus 1/5. What the y-intercepts of those lines are would vary depending on the initial conditions, but I can draw in lines of slope that I'm saying are plus or minus 1/5. These are dotted lines. They're not solid lines. When you're drawing a graph, whatever you draw as a solid line, with the exception of the x and y axis, is understood to be part of your graph. So make sure if you're drawing in these lines, just like if you're drawing in an asymptote, we draw those as dotted lines. Anything that's sort of a helper for your curve should be dotted lines rather than solid lines.